Normally, yeah, normally if nothing happening, okay, suppose translation happening, so there we can say acceleration is what d sine theta. Translation in motions, but in rolling acceleration is always less than d sine theta. So you should know this relation as well. So now we'll perform questions based on angular momentum and rolling motions. So we have a questions below the dancer. The dancer is rotating about his own vertical axis on its most horizontal floor. I omega L and E are momentum inertia, angular velocity, angular momentum, rotational kinetic energy of the dancer. Respectively, below dancer stretches himself away from his axis of rotation, then the following choices choose. Basically, see, if a dancer will stretch herself, so basically what will happen? Moment of inertia will increase because of distancing. I already explained the concept of distancing. If you don't know, so your teacher will explain in your classroom that what is the concept of distancing. And angular momentum is always concept that is I into omega is concept. If I is more, so angular momentum will be less. This concept, using this concept, we can solve these questions. So correct answer for this question will be I increases and omega E decreases, but L is constant. So omega is angular momentum, angular velocity. So angular velocity is decreasing, so obviously rotational kinetic energy is half I omega square, half I omega square. So rotational kinetic energy will also decrease. So this way we can solve this question easily. It's easy questions, we can solve it. Okay, so now we are moving for next question. If a polar ice caps melts, then the time duration of one day, okay, increases. So basically, what happened if polar ice cap melts, it will come to equator. So decreases does not change, so increases. Okay, so why? Okay, because if I'll ask you, suppose if I ask you what is time period, so time period was 2 pi I by md. If you suppose if you use this relation 2 pi I by md, so basically what's happened if you are using this concept, so time period if I will increase, so you can say time period will increase. Okay, so you can solve this question other ways as well, and give you the one idea, for this question. A hollow sphere partly filled with water has moment of inertia I when it is rotated about its own axis, and angular moment of omega. If it's on angular speed is double, then its moment of increases because increases. Moment of inertia becomes okay. So obviously, angular momentum is conserved again, and I omega is constant. Okay, again the omega is double, so moment of so if its angular velocity is double. Angular velocity is double. Okay, so when it is rotating with the axis at an angular speed omega, its angular on velocity is double. Its on angular speed, then moment of inertia becomes okay. So if you are conserving the angular momentum, if you're conserving the angular